Thanks, Luis, for that great introduction. I need you all to help me out for a bit. So I come from Seattle, Washington, which is on the other side of the world. I'm still feeling the flight. But to prove to my bosses that I came to Malaga, Spain to actually do work, if you all could smile and wave. Great. Thank you. I'll put this away so that we're not distracted by it. All right, so Luis kind of alluded to why I'm wearing the shirt that I'm wearing. I'm going to start off, I'm going to digress a little bit, go off topic, just for a minute or two. So every conference I speak at, I put in a bio, and in my bio, I list my sports teams I like, because I like sports. This is the one and only conference that played with me on this. And so, I believe it was Luis, took Borussia Dortmund, put this nice message that nobody in Malaga would support such a team, even to the extent that when I put in my promo video on Twitter, he asked, would I dare wear this shirt here in Malaga? I dare. So, here's what I need you to do. I need a little bit of help here. To continue with this conversation, if you could take a picture while I'm speaking, post it on Twitter, tag me, tag JOTB, that would be great. Not only for them, but also for folks that are following back home. So that is why, the story behind why I'm wearing such a bright shirt today. But the reason why you're here is to hear about a story that our company went through. I work for a company called Ingress, and we recently developed a Kubernetes Ingress Controller. And essentially what I want to do is talk about our experience with looking at the problem, designing it, and building it, and let you know kind of the trade-offs that we made and some of the reasons why we did it, how we did it. But the thing I want to start with and make sure that we all understand, I don't usually like to talk about my company and all its features and feel like a sales pitch. This isn't a sales pitch, but you do have to know what Ingress is, what Ingress provides, what our goals are, and why, so you can understand why we made the choices that we did. So I am going to be talking a lot about Ingress today, and I'm going to be talking a lot about Kubernetes today. And so I'm going to go over those things, but the hope is so that you can see the mindset of where we're coming from, and then how and why we did what we did. The name of today, the lesson, is trade-offs. We had reasons, right? When you make software, you have reasons of making various decisions. You say, well, maybe we could go this way, or maybe we could go that way, but we have to see what we want to do and why. And do we need the gains from this decision first, or the gains from that decision? And so I want to share some of those trade-offs that we had as we built this thing and we decided how to construct it and where we're going with it. So think of a time when you built something new. You have a new application, new piece of software, a service that you love. It is so beautiful. You don't care that it's green. You don't care that it has little things pointing out of it, but you think it's the most wonderful software application in the world. And you just need to get it out to your users because you think that the moment you get it out to those users, they'll feel the same way. The problem is there's a gap, right? You have to get your application from your machine or from some data center or some service provider. You have to get it out to your customer. There's a lot of things you got to know to get it there. You have to know about networking. You have to know about setting up NATs and DNSs and certs and all those things. And that's just to get the service out once. If you build another service, you got to do all those same steps again. If you take it from your home machine or your work or wherever, and then get it up into some other service provider, you have other things you got to think about, and other network settings you have to figure out, and other things you have to understand about the connectivity of getting your application out into the world. And that's where Ingress lives. Ingress makes that possible to be portable so that you set up your network settings by passing your traffic through Ingress. Ingress handles all of the other settings for you. It runs, most of the time it runs as a CLS, or a CLI, not CLS. A CLI in your terminal, it's an agent that you have a command that runs, and you say ngrok, you point it at a port, you tell the protocol you want, and then you can even set up the domain. And that domain, if you want to have that desired one, gets returned back and says, ngrok says, great, thanks for that information. All traffic going to this domain is going to go to that port on your computer or on whatever machine this ngrok's running on. The reasoning behind all of this was an idea that our founder had. Alan Shreve was the guy who invented ngrok, or the founder, we'll say, founded the company and started the project. But if you think about it, when it comes to networking, we still work bare bones. We still work on each individual process and step that we have to get that set up. Almost everything else about our application development has been abstracted out. We use frameworks for our front end, frameworks for our back end. When you're working with APIs, you're usually working with an SDK. You're not like building an HTTP request and then every single time you say, oh, I'm going to work with the GitHub API, and so I'm sure I'm working in Ruby. I'm sure they have a Ruby SDK. Then I can just work with my Ruby objects and abstract that out. The idea with ngrok is we're abstracting out that network connectivity. You say, yep, I trust that you have this. I don't have to think about it anymore. So going back to our little service that we built, our beautiful little green service with little arms flying all different directions, it's growing. People love it. People are expanding with it, and they want to take it, and you want to take it to more people. You want to add more things to it. You want to add more services to your application. So you start thinking like, all right, I'm going to take this thing, and I'm going to expand and probably run it in a container. And then, so with that container, I can take it, and I can make it portable. I can add things to it. And in that container, to level set, I'll just level set here. Containers are the virtual computing environment, portable. Not running on a virtual machine, it's just making it possible to have the code and the dependencies that you need all encapsulated in one spot. But as your application grows, you're going to get more and more containers, right? So you're going to need something to orchestrate all those containers, making them work together. And that's where Kubernetes comes in. Kubernetes makes it possible so that you can have those containers and they can work together holistically to make it possible to get your application and make your application run. We're going to talk about a few of the different Kubernetes today. There's a lot to Kubernetes. So much, there's so many different settings, objects, terms, nerd knobs you can turn to make things happen. We're only going to talk about a few. We're going to talk about Ingress and the different objects that you need to know leading up to Ingress. For starters, because a lot about Kubernetes is learning the terminology, learning the definitions of different terms that maybe mean something in one space of your life, and you come into Kubernetes and realize, oh wait, that means something else here? Yeah, it does. For instance, containers, while Kubernetes is known as a container orchestration system, it actually doesn't, containers don't run on it specifically, okay? The atomic unit in Kubernetes, or the smallest thing that you can have, is a pod. A pod has a container that runs inside of it. Now, you can have multiple containers. It's possible. People do it. However, today, we're just going to keep pods and containers as a one-to-one relationship. And there's a lot of arguments about, keeping things clean, right? Having one task per pod, per pod, so that you can understand where things are and how things are routed around. As folks sometimes might need to have multiple containers per pod, they can do that, but the thing is you don't do that to scale. When you're scaling, you add more pods to your cluster. You don't add more containers to a pod. That's something to keep in mind as you're thinking about how you would set up your Kubernetes. So in the spirit of abstraction, we're going to abstract out our container. You just know it's there, because as the diagram gets bigger, we know that we have our pod and the container inside of it. So our application's getting bigger. We're adding more pods to our system. And those pods need to be able to communicate with one another. And that's where services come in. That's right, service. This is capital S, proper noun, service in Kubernetes. Not to be confused with the generic term of service that we use for everything else in software. The service in Kubernetes makes it possible so that the pods actually have that network traffic. It understands which network traffic needs to go to which pod. So when the pods communicate, they're communicating through the service. That type of communication between the pods is called east-west traffic. As you're digging into things and learning things, you learn how, okay, if you hear about east-west traffic, it's happening inside the network of pods inside of your Kubernetes cluster, and it's happening through the service. However, if you want users to actually use your pods, then you need to get traffic from outside the cluster, inside your cluster. And so that's where Ingress comes in. This is the object that you configure so that users can get access into your application or into your cluster of pods. And with Ingress, that's called north-south traffic. Again, these are things, I point out points that for me, when I was learning them, it's like, okay, what are they talking about? It goes back to that terminology bit where it's like, okay, this is a neat area where I'm learning lots of things, but if I can understand what they're saying, you can understand a lot better with what they're trying to do. So with Ingress, an Ingress object can do lots of things. You can have load balancers. You can set up rules for things like, for like exposing a URL to expose the specific services. You can have name-based virtual hosting that is configured so that you can have your application have access to, again, to your users. A lot of controllers can make up a single Ingress. You can have one or many. A lot of different areas inside Kubernetes, they'll have other types of controllers and other types of objects that will spin up when you actually spin up your cluster automatically. Ingress has to be defined. So if you're going to set up Ingress, you define Ingress to get that working with your application. A common setup looks something like this. You have your cluster, and then you have maybe an Ingress controller for Nginx, which provides a proxy to your cluster. But then you probably also have a separate load balancer. So in this case, it's orange, so we'll assume it's Amazon, right? So you're running it on AWS, you have the Amazon load balancer. But then if you were running on GCP, you'd have the Google load balancer. Azure, you have the Azure load balancer. Or you can have a third-party load balancer. But you have separate pieces that make up your Ingress. If you took your application and decided, wait, we want to move to a different provider, then you have to change your load balancer or change that. So our journey at Ngrok began a few years ago with our founder, Alan Shreve. He was on that big yellow slide. He was an engineer at Twilio, and he worked on the webhooks there. He needed a solution in his personal, as he was working on his job, to expose his local host so the webhooks had a destination, right? So he would be working on these webhooks from Twilio, and he'd have code on his machine. He wrote this little utility. I want to expose this port. You're going to give me this URL. And he thought, oh, this is really neat. Shared it with his friends, shared it with his coworkers, and it caught on. Then he started sharing with the community. It started growing. Then he realized, wait, people could actually pay money for this, and I could live, this could be my job kind of thing. And it just kept continuing to grow. As he built out that company, he thought, well, now I'm going to make a company and have a startup. It's one of the first things a software startup thinks about when they're thinking about a new application. Which one, right? I mean, the monolith definitely has some advantages. You can have a lot less complex infrastructure, but microservices is the way to go, right? This is the way we're supposed to build things. And so he had a conundrum where he thought, all right, what's the best? I could either go with as far as monolith or go with scalability with microservices. And he actually came up with sort of a mixture, a hybrid. He wrote a blog post about something he called the neo monolith. But he also called it the Lego monolith, and that's the one I like more because I understand what Legos are and I don't know what Neo is. And so in a sense, he has a structure where he has a single monolith, a single box, that has a series of services that have all the same, and they're all running on the same port. That way, he can have all the advantages of having everything running in a monolith, but then he's already set up so that when he wants to take it to a service-oriented architecture, he's able to piecemeal take out each service and run it in its own environment. It worked out pretty nicely, and he wrote a blog post about it if you want to look at it at the bottom there. And so that's how we were set up for the future a little bit. So as he expanded the application, when he was in this setting, he was able to take each box or each monolith or Lego monolith and just copy it. If he needed to scale it, he would just copy the thing that had all the services in it. But with the services all having the same name, same ports on all the different environments, he wouldn't need any extra infrastructure for searching for the services or scheduling the different services to be running. They were able to find each other and know where each other are. Now remember, this is the generic term for service, not the capital S Kubernetes service. So with that, we were able to, so when ngrok decided to go to a more service-oriented architecture, we thought, all right, we're going to start adopting containers, we're going to start adopting Kubernetes, and we were starting setting things up. We already had the services set up. However, when we have a product that we wanted to essentially dog food, we wanted to use this thing. We knew that we could provide connectivity, we could provide Ingress with a platform that we were providing, and we wanted to be able to provide it through ourselves on Kubernetes. And we kind of got a way to do it. And we did it. We set up something where we set up ngrok as its own service or in its own pod. That CLI I was showing you before, that CLI, we essentially that binary, put it in a container, put that in a pod, made that its own service. It exposed Nginx, which exposed the rest of the application or the rest of the cluster to the world. Yeah, I mean, it worked enough that like we had other community who actually did the very similar things. In fact, this is the diagram that they set up to show how they were running things. It wasn't ideal. In fact, it worked, but it didn't quite work. It was not quite a sidecar either. It wasn't really a sidecar. It wasn't really what we wanted. It was something kind of in the middle. I just really love this picture. So it kind of was a sidecar. And essentially, in our case, we needed to take that application. Every time we wanted to update ngrok, you had to change out that pod. And in our case, code and get a service that we could provide to customers. So what we had and what the users had started separating. I started becoming two different things. And we thought, all right, wait a second. We want to be able to provide Ingress in Kubernetes, but we also want to have it for ourselves. We can't have two different things. So we need to take a step back, and rather than keeping writing, actually think about how we can make an Ingress controller for ourselves. So the first things we thought about were architecture, and we needed something that had an idiomatic API, which means it has all the expected fields that you would have. If you were using other Ingress controllers, then you and a certain set of values that you would put into your application or put into your Ingress configuration. And so we wanted to have those same things. We also wanted to be able to integrate seamlessly with other parts of Kubernetes. As I mentioned before, you can have multiple Ingress controllers or multiple controllers to set up a single Ingress. So you want to be able to make sure that they all work together, which kind of goes back to that idiomatic API. So there were some things that we had to do internally, because we saw that, okay, these are the different things we needed. All right, we also need certain features inside of our own product to make sure that we could provide the service that we needed for our customers. We needed to have load balancing, encryption, authentication, and remember how we started with webhooks? We need to be able to still provide a webhook verification for ourselves. And so these are some of the things we had to look at, and so we had to make some changes inside of our own application, but also make our own application a little bit nicer to work with when adding it to an Ingress controller. Ingress controllers, as in many things in Kubernetes, are written in Go. And coincidentally enough, so is ngrok. And we had this idea where ngrok runs as a CLI, runs as an agent, and you can run it outside of your code, but what if we took those things and put them together? And so we developed recently an ngrok Go library that actually took ngrok, embeds it inside of your Go application, your Go code, so you have a library inside of your application where you can set up your network settings inside your app. So rather than just running a net.listen, which same interface, we took ngrok.listen, and now you pass in, say, a domain or some CIDR settings to restrict your IPs, or you could put a circuit breaker or put some auth inside of your application. But you have it all set here so that when you run your application either on your machine or in another location, it all has the same settings. You don't have to worry about the settings anymore. But it made it vital for us as we built our Ingress controller. Now we could dynamically spin things up rather than having to shut ngrok down and then start it back up to add new settings or add new features, add new tunnels for different endpoints. We can do it in the code. So that way when the Ingress controller, as it's sitting there looking for changes, Ingress controllers are constantly looking for changes to we can dynamically do it with our application. So that library was vital for us to make it possible for building out our Ingress controller. So if you remember the diagram I showed before, right? You had the cluster, you had Ingress controller, you had the separate load balancer, two separate things. We now have a little bit more of a situation where you just take the user, they'll pass through ngrok, and then our Ingress controller gives them access to that platform. And then their cluster can be exposed with the services that they need, but it was also with the services we needed. Because that's essentially, a lot of times when we think of our applications, why we build out certain things, a lot of times we say, oh, well, I need this, so I'm going to build this thing. And then it's like, well, if I needed this, don't other people need this too? So that was a very similar situation for us. For our development, there's a couple of things if you're interested in building Ingress controllers. There's a couple of things you want to look at. The controller runtime provides the standard libraries that essentially lays the groundwork for building Ingress controllers. But then you have the Cube Builder framework that gives you those guide rails. It gives you the understanding of how things are supposed to be built. Both of these, I believe, are managed by the Kubernetes project and the folks that actually do Kubernetes. Also with Cube Builder, it gives you those tools like logging, telemetry, things that make it, they give you a much a bigger advantage to start building. Essentially, they're abstracting out the bits and pieces of dealing with the Kubernetes APIs and the bits there, right? So they're making your job easier to get you going. So again, it's all about abstracting things out. So in Kubernetes, there's in the Ingress space, there is a development happening right now where we have Ingress controllers, but then there's also this thing called the Gateway API spec. And folks who are on the bleeding cutting edge of Kubernetes, they a lot of times will ask, well, why don't we go with the Gateway API spec? And so we had that trade-off. It's like, well, we could go with the one that's kind of the new thing, the new shiny, which is really tempting, right? Because as developers, we love new shiny. Or we could go with the tried and true and the trusted one. And the advantages of going with the Ingress controller, which is what we did, is that it's widely used by the industry, but also that the community already knows how to use it. They know they're not having to learn what's in this ngrok product and what's in this new standard, they already know, okay, I already know the Ingress Controller standard, so I'll just go with that. But more importantly, it's what we use. We needed it right now, so that's, again, one of those reasons why we took that. If you look at the Gateway API documentation, as every project, they say, oh, we're people using it, and you look at all the and they say they're I love you, HashiCorp, but I don't know. I actually really do love HashiCorp. They're great. So the Gateway spec is still in flux. Folks, it's sitting there in our future. It's sitting there in everyone's future, but not quite yet. One of the things that the Gateway API spec promises is support for more than just HTTP and HTTPS. With our situation, with our platform and our product, we want to provide more than just HTTP and HTTPS. And so that'll be a great thing to adopt going forward. Again, this is going to be the standard going forward. But as one of my engineers that I was talking to said, it's also just everything that Ingress is, but better. So think about that. As you're looking at Ingress, API Gateway is the future, but it's not quite here just yet. So back in January, I believe, was when the call for papers for this conference was. I proposed this talk. We proposed this talk to get software goes. We have goals. Things are going to happen. We're going to be using it. Not quite yet. So, project is still in beta. It's out. It's available. But there's still some hardening from a few security things that we're trying to harden up. A few edge cases that we're trying to make sure are solid before we can really give it a stamp of approval and say, you can use this in any situation. We're currently using it internally. We're using it on our infrastructure cluster for our CI processes. And it's working great, but as I mentioned, there's just a few security edge cases that we're working through to make sure that it's very solid before it uses external data. Which leads to my invitation. If you'd like to help out with an open source project, give us feedback. You can sign up here. I can give you a free account to ngrok for like a free pro account for 90 days if you'd like. So coming up in the future, obviously we want to go general availability. We want to do V1. We want to get V1 out there for the world to use, and then look at the Gateway API spec. As we make that transition, there's a lot of tools that are available to make Ingress controllers and transition them to Gateway API. But we wanted to walk, as I mentioned before we could run. And so that's why we'll do that one next. Here's some of the resources of the things I was talking about. A lot of the documentation of the different pieces, things like the controller runtime, queue builder, the Ingress controller, our Ingress controller, the Kubernetes Ingress controller documentation, and then the API gateway spec. That's all available there on those links. And if you have any questions, you can reach out to me. You can find me on any of the socials that are available. Bottom 2 came out in like last 6 months. Something like that. So it's still playing with those, understanding if I'm on them. But if you really want to get a hold of me, it's probably Twitter. But yeah, I'm Scott McAllister, developer advocate at ngrok. And thanks, y'all, for listening.